November 18th, 2015. I'm starting to learn that many scientists, astronomers, astrophysicists, they have their hands tied behind their backs. They're not allowed to overview the stars as they actually are. They have to agree with everybody first. So it's this perpetual bullshit in, bullshit out kind of stream that was pointed out on an online forum to me. And it's very true. They take all the wrong ideas, they swallow them, they regurgitate them, and it's still the same wrong ideas. I'm going to need a lot more patience, even though it's been over 4 years. It's probably going to take at least another generation of time, maybe 20 years, before people really start to get it. I also noticed on the Arxiv paper, Arxiv is spelled A-R-X-I-V, that is held at Cornell, that some scientists, instead of using the definition or the word planet or exoplanet inside of their abstracts, they use the words companion. Companion meaning if you have a star and then they say, oh, it's companion. And it's good that they did that because there's no definition for planet that's unambiguous and that actually applies to exoplanets. This is because they don't understand that they're actually just evolving stars, and we've already corrected the definitions between those. They're both called astrons. You have the young astrons, which are called stars that are hot and bright and big, and the old ones, which are the old astrons, called planets or exoplanets. For those who don't know, you have young hot stars, and according to the Harvard spectral classification, it would be a OBAFGKM, or Oscar Bravo Alpha Fox Golf Kilo Mike. And the sun, as it stands right now, is sitting at a G or Golf spectrum star, and it will eventually become a K or Kilo spectrum as it cools and dies. And this means we can study the K spectrum stars and their compositions and their actual behavior to predict what's going to happen to the sun. So we know exactly what's going to happen to the sun via the general theory of stellar metamorphosis. We don't need to rely on theoretical models. We can actually observe its next stage of evolution, which is a K spectrum star or an orange dwarf. K spectrum stars, like 61 Pegasi, I think it's what it's called. Not Pegasi. I can't remember what it's called. But Epsilon Eridani is one of the stars too. I think 61... I'll go ahead and annotate this on the page later. Annotate it on the page later, but I think that's the binary system I was trying to refer to. But both of those are K spectrum stars, and they have specific characteristics about their actual behavior, how they rotate, how the differential winds occur, what kind of metals and things can be found in their atmosphere, how evolved they are. There can be a whole lot of information that can be taken from studying those star systems. Eventually, those K or orange dwarf stars are going to become M dwarfs, which are red dwarfs, which means they will further cool and shrink and begin flaring a lot. That's the flare star stages. And of course, this happens over many millions of years. The star's evolutionary path is not something where it goes from a G-type star all the way down to the size of Earth overnight. So the attitude of Earth used to be a star isn't the Earth just skipped all the steps. The Earth actually had to go through all those other stages of stellar evolution before it got to where it is right now. And the hard rocky ball that it's in the center that it became. So a lot of the online discussions where they try to make the sun just evaporate its outer layers and then boom, it became an Earth. It doesn't work like that. You have to include all stages of stellar evolution. That's the whole point. It just doesn't skip stages just because. But I guess that really sums up this little talk. To really understand that stars undergo a metamorphosis, or a complete change of form, a transformation, is to really get how things are the way they are, why things are the way they are. Just looking at stars as mathematical things that you can model inside of computer programs, I don't think that's the future. The future is with sound, reasoning, and non-contradictory ideas. If you have stellar evolution ignoring the fact that stars lose mass and heat to solar wind, flaring, and coronal mass ejections, and you neglect the fact that the star is not going to remain the same size, it's going to shrink considerably. But establishment, they have the sun is expanding and becoming this giant red giant star with this, which is really quite strange because there's very few red giants and there's way more red dwarfs. It would make more sense to realize that stars are very uncommon when they're hot and bright, they're very young, and as they cool and die, they join the ranks with more and more stars that are much cooler, dimmer, and are much more evolved. Alright, I think that's a good talk for today. Everybody take it easy.